Welcome to this section of the Algebra Word Problem Tutor, and in this section we're going to have problems that are going to end up involving quadratic equations. And quadratic equations are just a giant fancy word that means equations that involve x squared or y squared, some term with a square involved in it, okay? And because of that, when you have a variable that's squared in an equation, it becomes called a quadratic equation. That means you're going to have two solutions. So if you have a regular equation with with no squares, you have one solution. And then if you have a square term, you can have two solutions. If you have a cubic term, three solutions. Something to the fourth power, four solutions, so on and so forth. But today, for this part of the word problem, we're going to we're going to deal with quadratic equations. So those are going to be equations that have two solutions. Okay. So the first problem is, for instance, would say something like the square of a number plus 3 equals 67. Find the number. Okay, so the first step is just to translate the words there to what we're trying to deal with. The square of a number, so x is our number, the square of a number plus 3 is equal to 67. Okay, that's how we write that down mathematically. The square of a number plus 3 is 67. Find the number. Well, the first thing we're going to do is get x squared by itself. So it's going to be 67 minus 3. We just subtract 3 from both sides. Okay, so x squared is going to be 67 minus 3, which is 64. Okay, and then in order to solve this, we're going to end up taking the square root of both sides of this equation. You're going to take the square root of both sides of this equation. The square root of a square is just simply itself. So we're going to have x on the left is going to equal square root of 64. But don't forget, anytime we put a square root like this, to solve we have to put plus or minus. I'll come back and explain why the plus or minus has to be there, but for now, just say, okay, when you put a square root like this, to solve for something, you have to put a plus or a minus. Okay? Square root of 64 is 8. So x is going to equal plus 8, and x is going to equal minus 8. That's what the plus or minus means here. So we satisfied what we said we were going to have. We said we're going to have two solutions because this is a quadratic equation with the power of 2. One solution is positive 8, one solution is negative 8. Now let's go see if this makes sense. Okay? Plug it back in here and just check our work. Positive 8 times positive 8, which is 8 squared, is 64 plus 3 is 67. If we take the negative 8 and put it in here, then we will have negative 8 times negative 8, which is x squared, we put in negative 8. Again, that's 64 plus 3, which is 67. So we get the right answer. And so both of these are valid solutions that totally make sense there. And because of that, that's why you have to put the plus or minus. Anytime you take the square root of something trying to solve an equation, you have to put a plus or minus there, because when you do that, you know that either the plus or the minus value will go back and that will be valid, okay? And I've kind of shown you here, even the negative value works because negative times negative gives you positive. And that's why you have to do that. Anytime you take the square root of something, when you're trying to solve an equation, you're trying to solve for some unknown variable, anytime you take the square root of something, you have to put plus or minus out there because the negative value is just as valid as the positive value is, because when you square it, it doesn't really matter if it's negative. Okay, so the next problem would say something like, one number is 2 more than another number. The product of the numbers is 24. Find the numbers. So we're just going to go in and translate these statements to math and try to solve them. So we're going to have two numbers. I'm going to call them x and y. And notice the problem starts talking about two numbers, so I'm going to have two variables. One number, I'm going to say x, is 2 more than another number. So we're writing that first equation. One number is 2 more than the other. Okay, doesn't matter which one you pick. I picked x as y plus 2. Okay, and the second part says the product of the numbers is 24. Product means multiply, so x times y is 24. Notice I have two equations and I have two variables, so I'm good to go. I need to have as many equations as I do variables in order to be able to solve it. So I have two equations. And what I'm going to do first is take this first equation, I'm going to plug it into the second one and solve. So plugging into x here, I'm going to have y plus 2, just taking what x was equal to and putting it there, times y is equal to 24. Okay, so let's distribute this y in. Y times y is y squared plus y times 2, 2y is equal to 24. Okay? Now, I can't really solve for y very easily here. I can't divide, like all the other equations we've done. We were just able to isolate y, but this y squared kind of prevents us from doing that. So what we're going to do is we're going to tackle this a different way. Let's take this 24 and move it to the left. So y squared plus 2y minus 24 is equal to 0. All I did was subtract 24 from both sides of that equation. And now I have this quadratic term here that I have to try to solve. So what we're going to do is we're going to factor this expression. If you remember back to algebra and how to factor. And we're going to put y here and y here. The reason we're doing that is because when we do our FOIL, remember how to multiply these two things, y times y is going to give us that y squared. The next thing we do is we look at the last number and we find out what times what could give us 24. And I'm going to say 6 times 4 gives us 24. And the reason I put it here is because 6 times 4, the two last terms multiplied together, is going to give us this 24. But it's negative 24, so one of these terms has to be positive and one of these terms has to be negative, and I also have to try to make a positive 2 in the middle. So just follow along with me here and say, if I put a plus here and a minus here, will that work? So before we even go on any further, let's make sure we factored this right. Let's go ahead and try to bust this out again and see if we did it right. So when we're multiplying, y times y gives us y squared, plus inside times inside is 6y, plus outside times outside is negative 4y. Okay, and then last times last is negative 24. 6 times negative 4 is 24. And then that will be y squared plus 2y is minus 24, which is what we were trying to do in the begin with. So my advice to you is when you're doing a lot of factoring, unless you're really good at it, go ahead and try to, after you factor it, heck, I do this all the time. After you factor it, make sure you did it right. Go through and multiply everything out. Make sure you did the right thing. So why did we do this in the first place? Why would we want to factor it? Well, we do that because this parentheses is like a term. It's a nugget. It's kind of together. This is another term. It's another nugget. It's together. And what we know is that when we multiply this nugget times this nugget, this term times this term, it must be 0. So that means that this term could be 0. If this term were equal to 0, then 0 times whatever this is 0. Okay? And also, if this term were 0, then whatever's over here times 0 is going to give us 0. So because we've split it up like this, what we've proven to ourselves is that this term can equal 0, y plus 6 can equal 0, okay, and y minus 4 can equal 0. All we've done is we've factored it out so that we can put this terms equal to 0, and we know that they can equal 0 because that makes the product equal 0, okay? And when we do that, then this means that y can equal negative 6, just subtracting 6 from both sides, and this means over here that y can equal positive 4, adding 4 to both sides. And these are our two answers. Now notice in this case we had a quadratic equation, okay, and which had a square term, and we got two values of y as a result, okay, which was good. Now notice we solved for the two values of y, but there are two numbers involved. We haven't found anything to do with x yet. Okay? But notice that x is equal to y plus 2. So taking this value of y, which is negative 6, okay, x would equal y plus 2, okay, which would equal negative 6 plus 2, because negative 6 gets plugged into y, which would equal negative 4. Okay? And using this value, the separate equally valid value of y, x would equal to y plus 2, which will equal to 4, plugging in for y, plus 2, which would equal 6. So what we have found is, try not to get confused here, we have two solutions. One solution is that y is equal to negative 6 and x is equal to negative 4. This is one solution. This is one unit, okay? The other solution is that y is equal to 4 and x is equal to positive 6. This is another solution, Okay, you can't mix and match these. These go as a unit. I found one version of y and the corresponding version of x, and I found another y and its corresponding version of x, so they must stay together. And so those are the values there. Now, you really always should try to check your work to make sure you even did this right. So let's go and make sure that they satisfy our equations. The product must equal 24. Negative 6 times negative 4 gives us 24. Okay? And x must be equal to y plus 2. X must be equal to y, negative 6 plus 2 will be negative 4, so that satisfies. And then using this pair, 6 times 4 does give us 24, so that's good. And x must be equal to y plus 2. So 6 is equal to 4 plus 2, which is 6. So it's really not that hard. You write your equations, you substitute in, and if you get a square term, you're going to have to try to solve it. We couldn't take a square root, we couldn't do anything easy, so we had to factor and set each term in the parentheses equal to 0, okay, which we then solved for two values of y. We knew we had to have two values of y because we had a quadratic term that had a square term, and then we found the corresponding versions of x for each value of y that we found. Next problem. If the product of two consecutive odd numbers is 195, find the numbers. So it's a short problem, but we know that we have the product of two consecutive odd numbers is 195. So we're going to have x and y be our two numbers. We're trying to find those numbers. And we know that the product of those two numbers is 195. We know this. But we know that we can't stop there because we have two variables and only one equation. So we have to have another equation. You have to have as many equations as variables that you have. That's the only way you can solve these problems. Any kind of problem in algebra. It's just a universal thing. Okay, now the next clue that you were given is that there were two consecutive odd numbers. So that would be like 3 and 5. Those are consecutive odd numbers. Or 7 and 9. Those are consecutive odd numbers. So you skip the even number in between them, and they must be odd. Okay? So how would you write that down? One number must be equal to the other number plus 2, because you're skipping numbers there. So if you take one number and you add 2 to it, then you must arrive at the other number. So this expresses the fact that they're consecutive odd, and this expresses the fact that the product is equal to 195. So we're going to proceed exactly in the same way as we've done before. We're going to take one equation, we're going to plug it into the other one. So y plus 2 plugging into this equation times y is equal to 195. Okay, we just took this value of x, plugged it in here. Okay, now let's go ahead and multiply here. Y times y gives us y squared plus 2 times y is 2y is equal to 195. Now there's not much you can do here. You got a square term and a term in terms of y, so you can't really add them or anything. So what we need to do now is move this 195 over. Y squared plus 2y minus 195 is equal to 0. Just subtract 195 from both sides. Now, I couldn't find a very good way to factor this. Factoring it would be a great way to go, you know, what we did before as far as taking the parentheses and finding numbers that would make it all work out. But I don't think that can be done here. So when you have a quadratic term like that, you need to use your friend, the quadratic formula, if you cannot factor it. Now remember what the quadratic formula is. The quadratic formula says we're solving for y, so y is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. That's what the quadratic formula says. Now in this case, a is equal to the coefficient in front of here 1, b is equal to the coefficient in front of the y term, which is 2, and c is equal to the coefficient here at the end here, which is just by itself is negative 195. If this quadratic formula business looks foreign to you, you need to go back and brush up on that, and that is in the Algebra 2 Tutor or in a textbook. But basically it's just going to tell you what's here. Coefficient in front of this is called a, coefficient in front of this term is called b, coefficient here at the end, which is just by itself, is just c, and then you just plug it in this formula, and that will give you the value for y. So doing that, y is going to be equal to negative 2 plus or minus the square root of 2 squared, because it's b squared, minus 4 times a, which is 1, times c, which is negative 195, over 2 times 1. Okay? And when you simplify this out here, what you're going to get is negative 2 plus or minus square root of 4 minus. Okay? And what you're going to have here is negative 4 times 1 times negative 195 is going to be plus 780, okay, over 2. So 4 times 195 is 780. It's positive because you have negative times negative there, okay? So let's keep on cranking through it. Y is going to be equal to negative 2 plus or minus the square root of 784 over 2, okay? And the square root of 784, believe it or not, actually works out to negative 2 plus or minus 28 over 2. Okay? So, one value of y is going to be equal to negative 2 plus 28 over 2, which is going to be 26 over 2, which is going to be 13. This is one value of y, okay? And the other value of y is going to be equal to negative 2 minus 28 over 2, and that's going to equal to negative 30 over 2, which is going to be equal to negative 15. Okay? So I get two values of y, which is what this is, by the way, that's why this quadratic formula has a plus and a minus, so you will always get two values. One value is positive 13, the other value is negative 15. Now let's find their corresponding values in x. So using this version here, x is going to equal y plus 2, which is going to equal 13 plus 2. So x is going to equal 15, okay? And using this version, x is going to equal y plus 2, which is going to equal negative 15, plus 2. So this version is going to give us negative 13. So let's keep it all straight, and let's say that we have two solutions, okay? One solution is going to be y is equal to 13, x is going to equal to 15. That's one solution. And the other one is that y is going to be equal to negative 15 and x is going to be equal to negative 13. That's another solution. So you again have two solutions. Each solution has x and y because the problem had two numbers to begin with. You had x and you had y, okay? Let's make sure it's right, okay? Does 13 times 15 equal 195? I think you could put it in your calculator and convince yourself it does. Does negative 15 times negative 13 equal positive 195? Again, it does. Okay? Does x, this one, equal y plus 2? Yes, it does. X does equal 13 plus 2. Does x over here equal negative 15 plus 2? Yes, that will give you negative 13. So these are the answers. The only thing different here is that this equation, or this expression, would not factor, so then we were forced to use the quadratic formula, which looks messy, but it gives you the right answer on all the cases. You just plug your a in, you plug your b in, you plug your c in, and you just methodically go through it, and you'll get your values. Next problem says, one number is 3 more than another number. If the square of the smaller number is 19 more than 3 times the larger number, find the numbers. Okay, so this is just going to be, you can read this 5 or 6 times and try to wrap your head around it, but really you just need to start writing down the equation that the problem is really trying to describe to you step by step so that you make sure you get it right. So let's just read it. You're going to have two numbers, x and y. Those are going to be the numbers we're trying to solve for. One number is 3 more than another. So start with that. One number is equal to 3 more than another. So write that down. The next sentence, if the square of the smaller number is 19 more than 3 times the larger number, find the numbers. Okay, so the next thing we have to do is figure out which one of these two numbers is going to be the smaller number, because it talks about the smaller number. You know that y must be the smaller number because you're adding 3 to y, and then x is going to actually be bigger than y since you're adding 3 to it, so y must be the smaller number. So when it says the square of the smaller number, you know that you must be writing y squared because that must be the smaller of the two. So the square of the smaller number is 19 more than 3 times the larger number. So this is how you translate it. The square of the smaller number is 19 more than 3 times the larger number. Okay? So again, you have two equations and you have two unknowns. That's perfect. That's what you need. So let's go ahead and start plugging in. Let's plug in for x over here. Y squared is equal to 19 plus 3 times x, but x is equal to y plus 3. Okay? So what this means is y squared is equal to 19 plus, let's distribute this 3 in. 3 times y is 3y plus 3 times 3 gives me 9. Okay? So far so good. Let's go ahead and continue simplifying. Let's add these numbers together. These are just simply numbers. Y squared is equal to 19 plus 9 gives you 28 plus 3y. Okay, now it looks like we've gone about as far as we can. You have a y squared term, you have a y term, and you have a term with nothing else, no y's at all. You can't solve for y, okay? You can't manipulate this somehow and get y by itself. You just can't do it because you have a square term here and a non-square term. So the best you can do is try to get everything on one side and try to factor. So let's subtract 3y from both sides, and let's subtract 28 from both sides and put it in this form. Subtract the 3y from both sides gives me the negative 3y. Subtracting the 28 from both sides gives me the negative 28. On the right, once I do all the subtraction, I'm just going to have the 0. Okay. So the next thing I want to try to do is factor and set it equal to 0. Okay. Factoring the left. You know that y has to go here and y has to go here because y times y will give me my y squared. What times what can give me 28? Okay, 7 times 4 can give me 28, so I put 7 and 4, and now I have to choose my signs. And I'm going to choose them with a negative and a positive, like this. Okay, because then I'll have negative 7 times 4, which will give me negative 28, and then when I do my inside terms, I'll have negative 7y and I'll have positive 4y, which will give me my negative 3y. But if that doesn't quite make sense to you, let's just go ahead and let's see if we're right. Let's multiply this out. Y times y gives me y squared. The middle terms multiplied is negative 7y. The outer terms multiplied together is 4y. And the two end terms is negative 28. So then once you add these together, you'll get your negative 3y minus 28. Okay, so you choose the first ones, you choose the end ones, and you play games with the signs until you get what you want there. Okay, so now that we've done that, what this does for us is we know this must be equal to 0 and this also must be equal to 0. Because that will make, either one of them being 0 will make the whole thing multiply to 0, which is what we know it's equal to. So y minus 7 must be equal to 0. And y plus 4 must be equal to 0, okay? Which means y must be equal to 7 over here. You add 7 to both sides. And this also means that y must be equal to negative 4, okay? All right. Now, we have the two values of y. Notice that x is equal to y plus 3. So, x is equal to y plus 3. Okay, we know this, which means that x is equal to 7 plus 3. 7 plus 3 is equal to 10. Okay? So all we did was we took this value of 7, we put it back in and calculated x. And we're going to put this, x is equal to y plus 3, which is equal to negative 4, plus 3, which is equal to negative 1. Okay, So what have we done in the end? This is one solution and this is the other. So what we have found is that y is equal to 7 and x is equal to 10. That is one solution. That's this one. Okay? We've also found that y is equal to -4 and x is equal to -1. That is another solution. They're both equally valid solutions. Neither one is better than the other. It's just that you have to have two of them, again, because you have a square term. That's what I'm trying to drill into you. If you have a square term, you're going to have two solutions. If you have a cubic term, you will have three solutions, and so on and so forth. That's just the way the math works out. Final problem of this type says the sum of two numbers is 9. If the square of one number is 3 less than the other number, find the numbers. So again, two numbers, the sum of the two numbers is 9. If the square of one number is 3 less than the other number, find the numbers. So we're going to have two numbers. We're going to call them x and y again, just like we have been. Okay? The sum of two numbers must equal 9. We know this. And the second part says if the square of one number is equal to 3 less than the other number, okay, then find the numbers. So those are the two equations. The square of one number is 3 less than the other number. And the sum of the numbers must be 9. So I have my two equations, and I need to go ahead and solve these two. So what I want to do is I want to plug one into the other. So the first thing I'm going to do is I'm going to take this equation and just solve for y. Y is going to equal 9 minus x. Just subtract x from both sides. Okay? And then I'm going to take this and plug it into this equation. So x squared is equal to y minus 3, but y is given by 9 minus x minus 3. Okay? All I did was I took this y that I found from the first equation and plug it into the second equation. Okay? So x squared is equal to 6 minus x. 9 minus 3 gives me 6 minus x. Okay, notice I've got an x squared, I've got an x, a negative x here, and I've got a 6. I can't solve for x easily. I know I've got this square term, so the best bet I'm going to have is to factor. So let's move all of these things over here. Adding x to both sides is going to give me plus x. Subtracting 6 from both sides is going to give me that, and I'm going to have 0 on the right. 6 minus 6 gives me 0. X plus x gives me 0. And then adding the opposite brings them over. Okay? So then what I need to do is factor. Okay? I know I'm going to have an x here and an x here because that's going to give me my x squared. And then in order to do this, I know I'm going to have something times something can give me 6. And I know that 3 times 2 can give me 6. Okay? And I also know that if I put a plus here and a minus here, I believe I'm going to get the signs that I'm looking for. Because when I do it that way, 3 times negative 2 is going to give me my negative 6, and my inside term is 3x, and my outside term is negative 2x. That's going to give me my x in the middle. But if you can't do it that much in your head, that's okay. You just play with the signs and check your work. X times x, I'm just checking now. X squared. Your inside term is 3x. Your outside term, this one times this one, is negative 2x, and then your last term is negative 6. And I think you can see that when you add the two terms in the middle. So when you choose these signs, what you're doing is you're trying to do two things. You're trying to do it so that when you multiply these numbers, you get the sign here, and so that when you add the products of the inside and outside, you'll get the term that you want in the middle. So you're really trying to balance two things, and sometimes you'll have to play with that for a while before it'll work out for you. Okay? Now that we've done that, let's set this equal to 0 and this equal to 0. That's going to give us our answers. X plus 3 is equal to 0, and x minus 2 is equal to 0. Okay? So what this says is that x is equal to negative 3 because you just subtract 3 from both sides, and this says that x is equal to 2 because you just add 2 to both sides. So I've got two values for x. That makes sense because I had a square term here. I knew I would have two solutions. Now let's find the corresponding values for y. We have an equation that gives us y in terms of x. 9 minus x is equal to 9 minus x, but x is equal to negative 3. Make sure and keep your signs right. So y is going to equal 9 plus 3, negative times a negative, gives me my negative, a positive there. So then y is going to equal 12. Okay? And this 12 goes with the solution here. Now, y is 9 minus x, which is 9 minus this x, which is 2, so y will equal 7. So in the end, I found two solutions. X is equal to negative 3, y is equal to 12. That is one solution together. The other one is x is equal to 2, that's what I found, and y is equal to 7, the corresponding one there. And that is a solution. Negative 3 and 12, and 2 and 7. And those are right. So you can see I have two solutions, and each solution has x and y because I have two variables in this problem. You can't mix and match them. They have to be, they have to be together because I had two values for x and I solved for the corresponding value of y. So they have to stay together like this. And this is kind of how you would circle it on your paper. Neither one is better than the other. It's just that there are actually two solutions. And if you were to take these x's and y's and plug them in here, you would find that they would give you, that would satisfy both of these equations here. So this section dealt with problems that involve the quadratic functions, which are just a fancy word that means you have a square term. That's what quadratic really means. So in those equations, you frequently have to factor and set the factors equal to 0, and you're going to have two solutions that you get out of it. And if you don't have two solutions, you've done something wrong. So that's what to keep in mind. It's very, very important to keep in mind when you're solving word problems involving quadratic functions.